Okay, hey guys, this is Corey Witt here, and I'm going to attempt to do this extra credit project for nucleotides. So I draw out two diagrams sort of a DNA and an RNA molecule, so you can see, hopefully it's not the best drawing in the world, but it's the best I could do, and I'll explain and try to make it more clear as I go along. So let's start with the DNA side. So we were asked to describe a segment of DNA, and in this case it's ATG. What are ATGs? The ATGs are the base pairs. So all DNAs are made up of three main components. You've got nitrogenous base, sugar. So I've included the sugar, it's hard to see, but that's a ribose and a phosphate group. So the bases that make up the individual nucleotide sequence, or the nucleotides I should say, are adenine, thymine, guanine, and cytosine for DNA, right? And the main difference between RNA, which I'll get to in a minute, is they have the same except for thymine. RNA does not have thymine, and it instead has uracil. So that's the main difference in the bases between the two. So at the top, let's start with, so you've got obviously two double-stranded DNA. It's a double helix. How the strands run in a 5' to 3' direction. They are complementary strands, or semi-conservative, meaning that they run anti-parallel. So you can see this one starts at a 3', 5' here, so it is anti-parallel, right, on the way up, where it's 5' to 3' coming down. This allows the base pairing between different base pairs. So if we start from down here, you can see the guanine and the cytosine pair together, and the thymine and the adenines pair together, right? So that's the case all the way through. They're held together by hydrogen bonding, and you can see there's 3 hydrogen bonds between the guanine and the cytosine, and then the thymine and the adenine are held together by 2 hydrogen bonds, so not quite as strong. So the guanines and the cytosines are stronger bonds because there's 3. So it just means that it takes more to break them apart, and it would take a higher temperature to do that, to denature those bonds. And then, like I said before, you've got your phosphate group that is attached to a sugar. In this case, the sugars are pentose. They're 5-ring sugars, but it's a deoxyribose because it's a DNA. So you've got the deoxy group that's attached to this sugar. And on this side, with the RNA, it's just ribose, so you don't have that deoxynucleic acid. This is ribonucleic acid, right? Anyway, those are the differences. You've got this, because of those highly polar phosphate with oxygen with a negative, and then an OH, which is a hydroxyl group on the opposite end of the other molecule. It attracts, and so that creates that phosphodiester bond or linkage, right, that pulls those together. So that's for DNA. That's how the strands stay together and come together, and how each is attracted. RNA, basically the same thing. So for this one, we were asked to explain an AUG segment. So just like DNA, they're attracted by the hydrogen bonding, but adenine is paired with uracil instead of thymine on the RNA, right? So but the guanine and cytosine are the same, still the same. So everything's basically the same except for the thymine and the uracil. And of course, RNA overall is a single strand versus a double strand. It looks the same. It's hard for me to explain the base pairing without making it look sort of like a double strand, but it is, RNA is in nature a single stranded molecule, where DNA is double stranded, a double helix. The other main difference, and you still have your phosphate groups creating that phosphodiester linkage, but you've got this important on each of the bases. You have an OH, an extra OH group that differentiates between RNA and DNA. So that's how you can tell if it's a DNA molecule versus an RNA, is you would look on the bases for that little OH group. And I just included it there. Obviously it won't look like that off the molecule. This isn't a detailed of a molecule, but that's what it would look like coming off one of the rings that show the actual molecule, right? But everything else is still the same, 5' to 3'. Anyway, hope that was clear enough. And I'm going to end this now because I already went over 5 minutes. Thank you.